Okay, kids, relatively quick video here. Let's go over what a Coulomb is. Because we need to know what that is and how it applies to electrostatics and electricity in general. So a Coulomb. If I were to ask you, tell me how long a meter is. You all should be able to tell me. Okay. And if I said, how far is it to the back of the room? And give me an estimation in meters. Most of you can probably go, it's about 10 meters, maybe a little more than 10 meters. You know that. You know what a meter is. If I told you, if I asked you, is a gram a lot? Is a gram a lot? You'll go, no, it's not very much. Is a kilogram? What's a kilogram? A couple of pounds. We all have an idea of that. Is a second a large unit of time? We go, no, not really, not very long. So we know those units, but we don't know what a Coulomb is, or I doubt very much you guys know what Coulombs are. Maybe a couple of you do. What's a Coulomb? So if you were to get hit by 1 Coulomb of electricity, would that be like yeah, that tickled. Don't do that again, it tickles. Would that be what it is? Or would it be like, blow you up into smithereens? Okay, which end of the spectrum is a Coulomb? Well, let's take a look at 1 electron. 1 electron, 1 little tiny cute electron, has a charge of 1.6 times 10 to the negative 19th coulombs. Okay. Now this is on your AP Physics constant sheet. It's there. You don't have to memorize it, but you'll just write it down. Now here's what I want to do. One electron is equal to 1.6 times 10 to the negative 19th coulombs. Okay, not very many coulombs. But what if you had a Coulomb of electrons, a charge of a Coulomb? How many electrons would that be? You follow me here? I'm saying the 1 electron has a charge of 1.6 times 10 to the 19th coulombs. But what if you had a Coulomb's worth of charge? That's not a lot of charge here. Okay, that's not very much, negative 19th. But what if you had a Coulomb of charge? How many electrons would that be? Would it be 1? Well, geez, I hope not. A Coulomb would be a lot more than 1. If we do we invert this, take this and divide it by that. That's what I mean by that. Take this and divide it by that. We'll actually get that answer. If you have 1 Coulomb of electrons, that's equal to 6.25. And don't believe me. Don't trust me. I'm not a trustable person. Take this and divide it by that. You'll get this. 6.25 times 10 to the 18th electrons. Okay, so 1 electron is equal to this. 1 Coulomb is equal to that many electrons. That's a lot of electrons, people. You write that number out, that's a butt ton. And that's a lot of butt ton. It's a butt ton of electrons. So if you were to get struck by this many electrons, that could be a very bad day for you. So a Coulomb is a very large amount of electricity. It's a large amount. When we're talking about coulombs, we are talking about lightning bolt size stuff. Lightning bolts are, average lightning bolts like 5 to 15 coulombs or something like that. So this should be a little this should be a little lightning bolt, but it would still make you very sad. It could do you in depending on, where it hits you and how good your old ticker is. Okay, all right. So a Coulomb is a large amount of charge. So don't be messing with coulombs. When you shuffle your feet, if you got socks on and like a shaggy rug, back in my day, we used to do this at the school library. I was in 2nd grade, and the library got a new rug. And the first day we walk in, the librarian, because a brand new rug, she said, everybody take off your shoes. Don't bring your yucky, dirty shoes. Take them off. And we had to take our shoes off before we were able to walk on the rug. Well, that was a mistake. That was a mistake on her part, because we were able, she would read us a story. Usually Curious George was a good one back in 2nd grade. Curious George, the little monkey there. And after she read us a story, we would go out. We were supposed to go out and get a book and check out the book until whenever we had to turn it in, like a week later. And so the problem, well, it wasn't a problem for her, great for us, is that we had no shoes on, so we had socks on a new shag rug. It's like back in the 70s, man. This is shag was in. Shag rug, rub your feet, and the bookshelves are metal. Oh, yeah, we had fun. Shuffle. And we'd be shocking each other, and it was a great time. That was the last time she made us take our shoes off for library day. We had a good time, though. I remember it to this day. Awesomeness. Oh, those little charges, though, those, oh, yeah, those are in micro-coulombs or even nano-coulombs. So typical charges that we experience, like when we rub our butt on the seat of the car, rub your butt. Make sure you have clothes on, okay? We don't need that visual. Okay, rub your butt, and then you get out and you touch the car door. We're talking, nano or micro. You gotta go, ow, it's a micro. If you get it's a nano. That's the difference. Nano, micro, ow. See it? See it there? Yeah. Okay. So that's what a Coulomb is. It's a lot of charge. And so I just wanted to get you a little bit familiar with that unit that we're not familiar with. We certainly don't talk about coulombs in everyday life. We do talk about, even in physics, we don't talk about that very often. So that's a Coulomb, a lot of charge. Don't be messing with the Coulomb.